Hello. Hello. I think it's time to start. I hope you had a good lunch, and I really welcome on stage Jan Cooper, who will talk about clean architecture. Yay. So, usual stuff from organizers, boring stuff. Ask your questions in Slack. Use Twitter to expose your love. And yeah, enjoy.
You're welcome. Thanks very much. Hey, everybody. Who's heard of the clean architecture before? Who's heard of hexagonal architectures? Boundaries, controllers, and entities? A few? Okay. So the goal of this talk really is to kind of get into what the clean architecture is, where it came from a bit, and why you might want to use one, its kind of properties. And towards the end, we'll show you a repo where we have a kind of example of a transition to a clean architecture from a more, well, quite degraded kind of basic architecture. So I'm Ian Cooper. That's my Twitter handle. My DMs are open. If people want to ask questions on Twitter rather than Slack, etc., during the conference so that they get some privacy, feel free. That's my bio. I only ever really draw attention to the last point, which is, it's very easy to feel that you're there and I'm here, and that there's some kind of implicit, I'm smarter than you, and that's just not true. I'm no smarter than anybody here. I'm just confident enough to be on this stage. Please do consider yourself speaking at local user groups and conferences. It's a great way to see the world, but it's a great way to improve your knowledge, make sure you can articulate ideas, which really helps when you're explaining things to your colleagues. And once you get over the fear factor, and I certainly had fear when I first started speaking, it's a very, very positive thing to do. And all of you could be here, I promise you. Obligatory sort of mention, I work on an open source project called Brighter. It's a command dispatching library that effectively a bit like Mediator, but also does messaging a bit like, say, in Service Bus and Mass Transit. We're always looking for new contributors. If you ever fancied working on an open source project, we're pretty welcoming. So please do think about coming along and checking out the project and us. And the code we're going to look at right at the end does use Brighter, but that's not really the focus of this talk at all. We're going to talk about layering. Layering has got a bit of a bad press. Some people say, layered systems are bad. So we'll talk a little bit about what layering is and isn't. Then we'll talk a little bit about domain models, about how domain models get represented in domains, in layered architectures, why there is some significance to the way we do that. We'll talk a little, then we'll get on to kind of the clean architecture itself, and how that represents basically those ideas, and then we'll have towards the end some ideas about implementing it in code. So Bob Mine, who's over here, was the guy that really defined the term clean architecture, and he has a book. Actually, you can get most of the information you need in terms of what the clean architecture he's discussing is on his blog post about it. But he himself admits that what he's talking about is not a particularly new idea or concept. It's a synthesis of a number of ideas that have occurred repeatedly. So Alistair Cockburn famously created this idea, the ports and adapters architecture, quite often called the hexagonal architecture because the diagram used to represent it is a hexagon. Jeffrey Palomo created something called the onion architecture, and Ivar Jakobsen created something called the boundaries, controllers, and entities architecture. And there are other various examples, use case controller, DCI. They're all variations on a theme of a certain way of architecting your system, and they all have common properties. And so Bob really synthesized those ideas into the clean architecture. So we'll talk through a couple of those ideas to show the commonality of the patterns before we actually get into discussing Bob's synthesis towards the end. But the first thing I want to talk a bit about layering. Who here thinks they have a layered system today? A few of you? Who thinks layers are bad? One or two of you. All right. You're wrong, but we'll move on from that. Okay. So what is layering? Layering is one of the most basic architectural styles there is, right? And if you go back to Parnasse and people like that, Effective Architecture, that era, layering is one of the first architectural styles people created. And it's this idea that we could view our software as a layer cake or a wedding cake, right? Where the layers at the top stand upon and use the services of the layers below. So in this very simplistic model, at the top, I have a UI layer, where essentially all my presentation kind of code widgets live. Okay. Below that, I have some kind of domain layer. That's where my business logic lives, the stuff that my application's actually doing. And down below that, it has some kind of infrastructure layer. Some people call this the data layer because they only think about this as accessing the database. But really, this is doing any kind of external I/O, including talking to a payment system or talking to the file system. So we tend to sometimes call it the infrastructure layer. And in each one of these layers, your code is usually organized such that you have a facade over the majority of your code. And by a facade, what we mean is you have like a little narrow API, a surface area of some public classes and methods, or some exports from a module file, depending upon what your language implements. And that facade effectively says, here, I provide some services to the layer above. You don't have to understand the detail, you only have to understand the services that I provide. So classically, my UI calls to some kind of class that says something like orders service in my domain layer, which then controls access to some orders objects, which in turn talks some kind of repository or something in the infrastructure layer. Right? And we'll get into a bit more detail on that in a second. But one of the other things to see in these arrows is that I can only depend downwards. So my UI layer essentially depends on my domain layer, which in turn depends on my infrastructure layer. But nothing in my infrastructure layer can depend upwards to my domain layer, and nothing in my domain layer can depend upwards to my UI layer. And this prevents cyclic graphs, right? I can't have a cyclic dependency where things depend. In order to build this layer, I have to basically build the layer above, but I can't build that layer, so I haven't built the layer below. And you can see we also show a relaxed version. A relaxed version allows you to skip a layer in between. All right. The other thing to bear in mind is this. Sorry. Although we show these kind of three very conventional layers, that is just a convention. You can have any layers you want, and you can call them whatever you want. You could have 30 layers here if you felt that was necessary to represent what you wanted in your system. And this kind of infrastructure, domain, and UI sort of trinity is just a convention. And a lot of people assume that is what layering is. You divide it into those three groups. That's just a convention. And you can pick any layers you want. And so, for example, in DDD, they quite often talk about layering inside the domain itself. Okay, so why might I want to do that? The first thing is that one of the things you're trying to do in software all the time is make it easy for yourself to reason about the system. That's one of the key goals of architecture. And so what I'd like to do is be able to say, when I'm working inside the UI layer, I just want to deal with this concept of a domain layer down below without having to know all the details. Or more commonly, when I'm inside the, say, domain layer, I don't want to have to understand all the details of how I'm doing persistence. I'd like an abstraction that just says, persist my object, retrieve my object. So I can just in that layer think about, I'm dealing with business logic, and the notion of how I'm talking to the database is cleanly abstracted away from me. I don't have database code peppering my domain objects inside their implementation. I separate that out, so I just think about basically making a call to some data access object instead, which hides the complexity from me of that lower layer. So it makes it much easier for me because I'm only reasoning about problems at that layer, not problems that relate to other layers. I can substitute layers with alternative implementations. Given the idea that my layer has some kind of facade which says, here is the kind of public API you talk to, don't talk to all the details inside. So I've got a data access object which just has, create, read, delete, update rows in the database, and I don't have to worry about how that works, right? I could substitute one for another. I could substitute one way of doing persistence for another. Now, some folks say, that never happens. No one ever replaces their data layer. And I'd say to you, I've always replaced data layers everywhere I've been. Generally, it's not necessarily replacing a database. Quite often, it's replacing a framework that happens to you, that you move from one framework for doing abstraction to another. You decide that NHibernate's no longer the best cheese, and you decide to move your cheese to Dapper instead. And if you have a facade, you can probably re-implement without disturbing too much of your other code. If you think about something like a payment provider that you might use in order to basically take transactions from customers, you might decide to implement multiple payment providers in case one is not working. Or you may simply decide to switch payment providers because you decide that you don't like whoever you're using to do that. Having a facade helps you switch. And people always say, oh, well, systems don't really change things, right? So imagine once upon a time I decided that I was going to use web forms. And web forms was basically the best way of doing, .NET applications. And then at some point in the future, I think that's not the way I want to do it. I want to do MVC. If all of my code lived in the web forms pages, not basically in a domain layer, that gets very hard. But it's much easier if my code lives in a domain layer for my actual domain operations, and I can simply put a new UI on top and reuse the existing domain assets. And these things change us all the time. People who've built applications using WCF are now faced with the prospect of replacing WCF with something like gRPC. So change is really quite constant in any long-lived system. So this notion that, oh, you'll never change it is really quite false in my experience. So layers are very valuable to give you that option. You can defer decisions about layer implementations. What does that mean? Well, sometimes in software it's useful to defer decisions until the last responsible moment. And so, for example, when you're working at, say, figuring out how your domain works, you don't always necessarily have to understand exactly how you'll do persistence at that point. You can do your TDD against essentially your domain model, and then later on figure out how I'm going to persist stuff once you've got some of the more basic mechanics working. And you're minimizing dependencies. Because you're using basically a facade, the number of places that one layer interacts with the other layer is lower, right? Why is that important? Well, there's this notion in software essentially of coupling, right? Coupling says, my component understands how your component works. If you change your component, that change comes back to me. And coupling is what kills you in most software architectures. The big ball of mud, which is this, really bad software architecture example, is just coupling gone crazy. Everything is coupled to everything else. You can't disentangle anything. What we want to do is reduce the amount of coupling. So if we have layers, we only have a narrower amount of coupling between an upper layer and a lower layer, that facade, which means that it's much easier for us to change. And cohesion is the other property we care about. That's the extent to which things that change together live together, and things that don't change together are apart. And having basically layers is a way of us introducing cohesion. Because if the data layer or the payment provider changes its implementation details, that shouldn't affect the domain model. And I've worked on systems where people had no layers. And inside what you thought was a domain object, it would just do persistence at random during effectively some business operation. It would say, let's flush the state here, let's read from the disk here. And the problem with that is it becomes incredibly hard to make changes, because if you need to change how transactions work in the system, you have huge numbers of places to change the code. And it's incredibly hard to reason about, right? I'm not really sure when a database transaction might occur. So you really want to try and focus on getting low coupling and high cohesion in a good software system. And layering is your most basic tool to do that. When we talk about our domain layer, we can generally think about it as having two different types of logic. We can think about it as having domain logic, And domain logic here tends to be the rules of our business. So if I was writing an insurance application, it would be the rules that decide whether I'm going to insure your car and how much I'm going to charge you for it. Whether I'm going to insure your house and how much I'm going to charge you for it. And it has things like, are you a smoker for life insurance, right? And those are the rules, basically, of our domain. And they are things that the business talks about and understands. And you can go and ask a domain expert, and you can say, what are the rules we are encoding into our system? And then there's application logic. And the application logic says, in order to actually make this software work, there are probably a number of things we need to do in sequence. We may need to go to the database and get some data out. Once we've got that data out, we can use that to kind of hydrate our domain model and make it happen. And then we can basically, after we've called it, we'll need to save the results away somewhere in a database. Or we'll need to call externally to this system that gives us geolocation data, etc. And those steps in the processing of a given piece of work or a task are the application logic in the system. And so a quite common modification to that very simple three-layer diagram is to split our domain layer into two layers, a service layer and an entity layer. And there are two basic ways of doing this. The first way, we call it domain facade. And in a domain facade, in our service layer, that layer has very little in it apart from the actual application logic. All of the real power of our application comes from the entities that live basically in the domain layer. And these entities are things that essentially say we have state and we have behavior that is dependent on that state. So for example, I have an entity that represents an insurance submission, and it has some state, which would be things like, where is your house located? Do you have locks on the windows? Do you have a large open fireplace? Do your children regularly throw flaming coals around for entertainment? Those kind of things are the state, and the rules that go with them are the things that operate on that state. And most of our service layer is simply application logic that runs over that. So it's a very thin service layer that simply coordinates access to those domain objects. The other approach is called an operation script. And an operation script, actually, we say we don't have much of a domain. We really are some kind of CRUD-based service where essentially all we're doing pretty much is storing some data in response to users putting it in, retrieving it, updating it, and deleting it. And we don't really want to go to all the trouble of creating some kind of faux domain model that won't actually have anything in it. So we kind of accept at that point that most of the smarts of our application actually lives in what's called an operational transaction script that works with some very dumb data structures that actually just do persistence of data back and forth. And you just have to figure out which one of your applications you have. Do you have something that has genuine rules that you need to focus on, or are you doing persistence? And you don't have to make that decision, we'll see later, the same for the entirety of your whole application. Parts of it, you can use operation script, and the other parts you can use domain facade, depending upon what you're dealing with. So let's talk about this idea of ports and adapters. So this idea comes from basically Alistair Cockburn, and ports and adapters is really just a variation of layered architectures. It's a layered architecture with a slightly different set of rules. And when Alistair Cockburn came up with basically the ports and adapters style, he identified 3 layers. The first layer is the application layer, and that contains the rules of our application. We can think of it otherwise as the domain layer. It's a bit of a bad naming choice because lots of people think of the application as being the whole piece of software that I'm writing, and that's caused a lot of confusion for some people about how you interpret ports and adapters architectures, because we talk about ports wrapping in the application. But the application layer in ports and adapters refers to the domain model right at the heart. So it's where all the business entities live and where that goes on. The adapters, The adapters are essentially the concern that deals with the outside world, really. So it deals with input and output. It's how essentially we store data from the system. It's how we get data into the system. And it's generally how we act on it. And in between the two are the ports. And the ports essentially are how this adapter layer uses and communicates with the domain. So a diagram makes this a bit easier. This is conventionally how we kind of show hexagonal architecture. So the reason for hexagons is because he wants to give the idea of surfaces. So over here, for example, we have a user side, right? So conventionally, we split this into a kind of left and right. On the left, we have things that are kind of inputs, primaries, that drive a given operation. And over here, we have things that generally are used by that operation. So you can imagine here we have this idea in this outer box of an adapters. We've got HTTP or a GUI. So an HTTP with something like an API or even basically server-side rendered web code that effectively is where we're getting input in. Someone's filling out the insurance application and they're adding in all the data to the fields. Or a GUI might be some kind of like, WPF thing running on someone's desktop or even on a phone that's essentially talking to us. And that basically brings in the actors that basically use those adapters to give us basically request information. And in the center, these circles represent effectively the idea of this application. So these are domain objects which actually provide all the rules that we want to run. And the kind of line in between, if you like, the adapter layer and the central application layer are the ports. So the idea he wanted to represent was the idea of a port on a computer where something where you can plug something in, right? And so the idea is these ports to the domain layer where you can plug in these adapters. And the idea is you can have things as well like AMQP or WebSocket as a way of getting things in or getting things out by notifications. The database just is another adapter that plugs in to let you retrieve or write data. And all these things plug into ports, so ways into the application. So that's the adapter, that's the application, and in between there is the port, right? And the port essentially mediates this conversation. And you may have a given port used by a number of different adapters. So different types of UI could plug into the same port. And we'll see later one of the things is tests. Tests can replace UI and just plug into the port and drive the application. And so we can kind of revisit our layering diagram a bit like this. We can say, well, the layers now basically, rather than having just infrastructure and UI and domain, what we really have is this adapter, port, and application. And because all of the I/O is now represented by the adapter, infrastructure and UI essentially all live in that same layer. Right? So you have an adapter layer, and below it this kind of application, this domain layer which consists of the port and the application. And the rule is that we depend inwards or down again, right? But if you think of it in this model, we depend in towards the center. So here, effectively, everything goes down from the adapter through the ports to the application. So you can see ABC, we're going all the way down. Now that raises the question that pops up for us, right? Given that everything depends inwards, how do I ever save anything, right? Because if my domain model effectively is at the center, previously I had a model which said, well, I have UI, domain, and infrastructure. So the model would be, I call one of my domain objects, and it in turn saves some state to the database and back. And this model looks very different though, right? Because I call essentially my port to access as my domain layer, and then effectively I have to, at some point, call out via a port to the adapter layer. So what happens? How does my port essentially call an adapter layer because it can't depend upwards? And this is where the repository pattern idea comes from and where we effectively do what's called dependency inversion. In order for a lower layer to call a higher layer, because it can't directly reference it, what the lower layer does is it creates an interface. It says, I'm going to create an interface to represent something I want to call. So the port says, at some point, I'm going to want to call a database. I don't have access to the adapter layer. It's above me. So I need to implement an interface that says, I represent me calling the data. And then essentially when we build or when we run our application at runtime, the composition root, in other words, the first thing we hit, does dependency injection. And it says, wherever you need one of these interfaces, actually substitute in a concrete type from the adapter layer. So if I want to essentially have a way of accessing all of my customers' orders, in the ports layer, I may have something like iOrder repository. And then essentially what happens is at runtime, I use dependency injection, probably by an inversion of control container, to inject an actual concrete order repository in whenever I create instances of, say, my order service class. And people often say, the repository pattern is useless because it's just an abstraction over your data access, and you don't need that, right? But the reality is you can't do something like essentially a ports and adapters architecture if you are directly accessing your data, because your data lives in the adapters layer. And you're breaking the rules because you're not depending inwards anymore. And what I want to achieve is that this layer in the middle, this application layer, is just plain old C#, plain old Java, or plain old Python objects that are completely divorced from I/O concerns. That makes them very easy to use with TDD, because I don't have to worry about my TDD encountering I/O and having to mock that out. That doesn't exist at that layer. My I/O really only happens via my ports layer mediating a conversation with the adapter. It's either an incoming conversation where essentially something like a web request has come in on my API, and essentially that in turn calls my port and I exercise the domain, or it's a kind of outgoing conversation where my port says I'm going to need some data, so in order to get hold of that from the adapter, I'm going to talk to my interface, and then at runtime, the composition root, my main method, will inject in a concrete version whenever I need one, and so I'll be magically calling out to the correct thing. And that's where essentially dependency injection and inversion of control came from. While we're doing IOC containers, while we're doing DI, it's a support-led architectures, such that you can remove from your domain model the need to worry about concerns like I/O. Okay, let's move back a little bit. So, there's a guy called Ivor Jacobson. Anyone know who Ivor Jacobson is? You heard about Ivor Jacobson, anyone? Yeah? Okay, so he wrote this book, Growing Object-Oriented Software Engineering, back in the 90s, I think. He's the father of basically a methodology for kind of proto-agile called Rational Unified Process, but he's also really wrote this is a very good book on object orientation and object-oriented design. But mostly he's famous for this. Anyone know what this is? It's a use case diagram. So use cases are kind of a proto-user stories idea, right? And the idea essentially is what I want to show in my use case is what are the set of interactions that kind of make up this software requirement. So here you can see the idea of somebody writing a use case for being served in a restaurant, right? So I've got a client. That client basically goes into a restaurant. There's a waiter. I order my food with him. And essentially they receive the order and then they send the order over to the chef who cooks the food. Maybe essentially I also order some wine. And then the waiter, when he's signaled that the food is ready, basically serves the food and the wine, and then I eat the food and drink the wine, and at the end I pay for the food and the wine. And this represents, very crudely, a set of interactions. Notice that we don't drive down to the detail and essentially what serve wine or serve food kind of means. The idea is we're saying, what is the kind of flow of work that we need to build here to represent something that gives an outcome to an actor? And Jacobson, who came up with this idea, also came up with a bit of a challenge for himself. He said, I really want to represent this in software. I want my software to be capable of showing you that it's dealing with use cases. I don't want my software to focus on the frameworks used to build it. When I look at my code, I don't want what I'm drawn to be, oh, this is a MVC application, or this is a Rails application. What I want to be drawn to is, what are the use cases that my software is implementing? How does it implement those? So he came up with this model called boundaries, controllers, and entities. So a boundary object, he said, well, that's the thing essentially at the outside. That's what interfaces with the actual actor, the person driving the system, or the partner application driving your system, right? That's the external part of it. This is basically, by the way, UML notation. It still exists. The entity, he said, well, that's the thing actually that has the state and has the operations that have some dependency upon that state. It's the business logic, right? We discussed this idea earlier. And he said, and then there's a controller, been renamed sometimes an interactor, because people get this confused with the MVC pattern. So there's the interactor, and that mediates the communication between boundaries and entities. And his rule was effectively a boundary can't talk directly to an entity. It must do so through the notion of essentially an interactor or controller. And that creates this kind of model for software, right? So my actor talks to some boundary objects, which effectively these control objects, these controllers, talk to the entities. So we can see that that's very similar to what we're talking about when we talk about adapters, ports, and applications. Our adapter is really our boundary object, our port is really a control object, and our application is our entity objects. And why is that interesting? Well, one of the other things that Jakobson then says is essentially the controllers are where effectively you find the use cases. The implementation of your controller is essentially your use case. And those of you who have seen my TDD talk, one of the things I talk about is that the objective of TDD is really about testing your use cases. So what we're trying to test really then is against probably our controllers. And you can also find that the other person who got really interested in use cases and wrote a book about agile use cases was Alistair Cockburn, who went along to write hexagonal architectures. And Alistair Cockburn points out that the ports in a hexagonal architecture are where you represent the use cases. And so a key idea with this kind of system is that what we're representing at this boundary layer in between the boundaries, and at this layer between the boundaries and objects that can align, are the use cases. And what I, as a software developer or architect, want to be able to do as a benefit of this layering is say, I can kind of ignore the MVC framework. I can kind of ignore the repository doing my persistence. I can focus on what is the use case, what is the business requirement, and how is it implemented. And it's cleanly separated from those technology concerns and easy to test. And so our tests are just another adapter driving the ports, driving the interactor to actually exercise our code. And so rather than essentially driving it through a UI, we drive it through a unit test. And the port is this unit test boundary. Okay. And we may have some integration tests around effectively the adapter interacting with the port. We don't tend to test the adapter directly, so we don't tend to basically write code that spins up our controller directly and test stuff. We actually test what the controller is calling, because a system test on the outside will check everything's hooked together as we're monitoring. So don't write tests that essentially spin up your underlying .NET, ASP.NET MVC framework controllers, because then you've coupled your tests to a technology framework. And if you change your technology framework, you have to throw the tests away. But more importantly, you've clouded the picture of what you're doing. Your focus is intended to be on those use cases. Okay. So, what is this kind of clean architecture idea that Bob's come up with? So this essentially is a clean architecture, and it's very similar to the model we're talking about. At the center is entities, and we are using the same definition we've been talking about earlier from Jakobson. It is essentially classes that contain state, which they are encapsulating, and operations on that state. And the dependency is essentially the business rules for that basically apply to some state should be contained in the class that manages that state, right? The state doesn't leak out those classes, therefore essentially that's where my state for those belongs. Outside that, I have essentially, the use cases, right? This interactor layer effectively essentially has my use cases, and the use cases are what drive the flow of operations for using those particular entities. So that's where effectively I have my checkout use case for my online store, which drives the entities underneath, like the basket entity or the account entity, etc., that they're using, right? And that's one of the key benefit you should gain from using this architecture, is that all of this is just plain code without I/O concerns. That's easy to get under test. You've driven all that stuff that deals with essentially computing away and just dealt with the actual underlying core entities. Outside that, then our controllers, gateways, and presenters. And essentially what we mean by this at this layer is that's the kind of stuff that you're forced to write by your framework so your framework can interact with you. This is where your airspeed on an MVC controller goes, right? This is where effectively the code that you write that the framework calls, that's where that lives. And then outside that you have the framework, the devices, the HTTP itself. Okay. And this diagram in the corner represents the fact that the flow of control requires some dependency injection, because my controller effectively calls my use case input port, I do some kind of work, but I may want to output the results, and to do that, effectively say to a database, what I would need to do is essentially dependency inject that into my application. Right? So you can see a model here that essentially shows you that in a bit more detail. I've got my delivery mechanism, essentially HTTP, for example. It comes into a boundary layer, which might be my controller that I'm writing for my MVC framework. I've got in gray, basically, these data objects, because I don't want to pass my entities directly back and forth across the boundary. As I cross interface layers, I should essentially try and respect the fact that I can't pass entities up, right? I depend inwards. So I've got a request model and a response model, and the request model is coming in, it's from the HTTP, it's all my form variables, my query string components, and I've got a response model that will come back out. And my interface or interactor, that's where my use case is being written, is essentially a thing that's controlling my entities. Something like an entity gateway interface, which is at the same color coding as boundary as my adapter for talking to a database, for example. Right? So here on this version, you can see that kind of spoke about more concretely. I've got an API framework calling a web controller. It passes in a request model by looking at effectively the parameters on my HTTP and the form variables, turns them into a call to my web controller using the URI as well, etc. Calls my interactor, which then basically manipulates my entities and talks to my entity gateway and produces a response model in return. If I have essentially an MVC framework, it lives here, right? It's part of what the web controller is doing to essentially say, what I want to do is put the out onto effectively a view model, this idea effectively of the data that I'm writing in a testable fashion, because I can't really interact very well in unit tests with the view. So if I want to really test the presentation of my model, I'm going to use this kind of presenter view model pattern. But all that kind of code is at the same layer as the web controller, right? It's not part of my interactor or entity layer. And in the same way, this is how I talk to the database. I've got some kind of gateway, some data access object, some repository that's effectively abstracting my way to the database. Because again, I can't pass effectively, that directly in to my interactor, so I have to basically use dependency injection to do it. Okay. I find it's very useful when I try and implement this to understand the command pattern. So the command pattern, as I'm sure you all know, is this idea of saying I can encapsulate a call to my domain. It has some parameters, which are basically go into the constructor of the command, and typically the command has an execute method, and the execute method actually calls a domain. And if you think about that, you think a command's doing something basically on my domain. It contains some application logic. It's often a transactional boundary, right? You can see that the command is a natural fit for an interactor. It's something that essentially my adapter layer can use to interact with my domain layer. It encapsulates the interaction, and it encapsulates the application flow, the transactional boundary, and some of the I/O. So commands are a very good way of building that interactor, that port, right, or surface layer. And then they align nicely for me with the idea of ports. Here is a command that I can call from multiple places in order to make something happen. That is effectively my port over the application. command's very easy to implement, right? So you have some kind of interface saying execute with it, and you just do all the work in the execute method. So here, essentially, my boundary is effectively dealing with a command as the interactor, right? And I have a concrete instance of the command over effectively there. The other variation of this, which you'll see quite commonly, is what things like Brighter and Mediator help you do, is effectively to have a command dispatcher model. All the dispatcher does is it separates those parameters from that execution, and it says in order to make this truly effectively decoupled, you will fill out a command with just the state that you need, you'll pass it to a dispatcher, and the dispatcher will find a handler. And that gives us the ability for us to say, well, you don't even need to know at the level of the web controller what port implements this. I will find the port that understands how to receive these requests. So you're routing effectively to a port that understands how to deal with those requests. And that can be useful because you can set up basically a pipeline that lets you do orthogonal concerns like logging, etc., in that pipeline. All right? Okay. So we've got 10 minutes or so to run through, have a look at some code. I'll have to remember to mirror screens in a second, no doubt. Cool. No, that's all right. Let's have a see. Hurrah. How readable is that at the back? Thumbs up for good? Cool. Right. This code is on GitHub under CA tutorial. It is the world's most over-engineered Hello World application. It has a basically web controller here that takes essentially requests for greetings, where you can post greetings into it essentially. Where is my post? Ignore the console write lines, I'll come back to that a bit later. But I can post in greetings. I've got some entity framework going on there where essentially I'm saying, save my greeting and then get the greeting back and return back as the response to the post the greeting I've just created. And I can go and find, all the greetings that I've stored so far, or I can essentially go and get a specific greeting if I know its identifier. It's the application you all need, I know. You're thinking to yourself, wow, I could build a business on Ian's application. Okay, and you can see, so basically we have a number of branches. This down here in the bottom, and if you can see that, that's essentially Visual Code giving you an idea of the branch of GitHub you're on. And you can see what we've done here is pretty much gone for the non-layered version of our architecture. Everything is pretty much done inside the adapter layers controller. And the problem is, I've got a lot of repetition here, right? A lot of places doing this go and get essentially a specific greeting by doing essentially a bit of link from entity framework to go and get results out. I've got all this stuff which is pretty meaningless to me located in there. And even though I don't actually have much in the way of domain logic, it's a bit of a spray of kind of concerns inside my controller. Right. So the first thing I might think I'm going to do is, I think, maybe I'll introduce essentially a layer. I went to Ian's talk and layers are good, right? So maybe what I'll do is I'll say, let's have a nice little layer in here. So here what I'm doing now is I basically create a greeting facade. And rather than essentially putting all that implementation code directly in my controller, I've now got some separation. All the facade needs to do is say, or the controller needs to do is say, there's an operation that's dealing with this, right? And so here I can actually understand what this whole thing about all those console write line statements were doing. It's something about putting my greeting out, right? This regreet operation. Controller looks a lot cleaner. Okay. And actually, if I look at basically how this is working, I have this. I don't think you're that at all. I think, sorry, sometimes Visual Studio Code needs to be persuaded a little bit hard to change its opinion about where we are and what things it can see. So I don't believe you actually have that. I think you have something else. Where's my facade gone? Okay, that's interesting. Okay. Right. So ignore the stuff in green. That doesn't really exist in this project. The greeting facade here says, well, I've got these methods: add async, all async, delete async, etc. Right? And in a sense, I know I can reason about that more easily. I can deal with individual parts of it. Maybe it's easy to get under test. I've still got not a clean separation between the I/O and the actual everything else, but then this is a Noddy application, so it's really only got I/O. But I've also got all of the concerns around greeting in one big class. That could, in a real-world scenario where I've actually got some application logic in here, it's going to grow quite large. It could turn into one of those 600-line service classes that some of you may have seen. And as I look at that, I think also the other trouble tends to be with these things is, although there isn't much in this case, you can get big constructors that pull in loads of dependencies that relate to different kind of files. So what I might want to do instead is break that one up a bit, right? And I can say, this is, by the way, if you want to look at this code yourself, just moving through the branches is the way to do it. And if you use something that isn't quite as hostile to that, you won't, as Visual Studio, Visual Code rather, you don't have to keep changing this stuff. So I can break it up. And so rather than having one facade, I can have many facades, right? And so now I've got basically just broken it up. So every single operation on the facade is actually now a separate item. So I've got something for doing greeting, I've got something to greeting by ID. And the advantage of that when I go up here to my greetings controller is I get a certain amount of reuse now, right? So I've got this notion of retrieving a greeting by ID, so I can reuse that in my post to pull that operation of getting something back. And I'm already starting to get a little bit cleaner now. I've got things broken up. And I look at them and I think, well, hang on a minute. If I've got these facades that essentially are a single operation, surely I can just abstract that out. And really, that gets me into a command, right? So now I've got this notion of commands, which say basically, well, I've got queries and commands. I've got a query, I've got a command, and those are just the simple objects that I can then go and deal with. And my ports are essentially these commands and these queries. So my use case layer just asserts commands. Now, I haven't got much logic, but imagine I have some complex business logic. The application logic would be happening here, and in the actual greeting itself would be when my entity logic existed. So I've got delete greeting, add greeting. I've got this notion of regreet event, which basically is putting stuff out to the console quite separately. And my controller is quite neat. And finally, I can say, well, hang on a minute, what happens if I, whoops-a-daisy. I don't care, do that anyway. Okay, hang on. Git check out clean architecture with commands. Let me just do this the hard way. Oh, I'm in the wrong place. CD. Thought I had this opened. Oh, geez, come on, just let me do that. Sometimes I have to delete something, I think. That usually happens to me. Please move them at unchecked files. Really? Well, it's a new one on me. Command handler. Let's update that. Okay, can we commit that, please? Source control. I'll figure out what that is later, so I'll clean it up when you guys want to split stuff around, but that should hopefully fix it now. Right, sorry about that. So in this model, we separate the command itself, which only has essentially its parameters, from the handler. And what you're doing here, and this is basically using Brighter and a typical framework, is you're saying, I'm going to implement this handle method, which is effectively the command's execute method. I'll pass the command in, the dispatcher gets hold of that, right, and do the operation. But because I have essentially a pipeline, because I'm using a dispatcher, I can move off some orthogonal concerns. This is the way that Brighter represents that. Essentially, it puts attributes onto your handler where you can say things like, I want to log this request, and I want to use poly to effectively provide me with retry or circuit breaker operations. And that's just a typical example of why you might use a dispatcher. All right? And over in my controller, it all looks very similar to the way it looked before, which is essentially to have this kind of model. All right, free processor request executing. All right, let's get back to the presentation. We're almost done. Okay, that's the demo. All right, so the current slide. There's only just a little box to remind you to vote at the end. There's no actual text on any of the slides. Okay, so just a kind of final recap. I'm sorry I've overrun slightly. The clean architecture is used to cleanly separate your application domain code and use cases around that from the infrastructure concerns. And it does that by making you obey the rule of always depending inwards towards essentially code that has less infrastructure and more just plain old Java or C# or Python that it's easy to get under test and easy to manipulate and easy to reason about. And the real advantage of that is that by divorcing yourself from these concerns, it gets easier to test and easier to replace stuff and easier to focus on the part of your code that really matters, which is the use cases driving your actual business behavior, not the frameworks. And the trouble with the more traditional models is my focus is really taken by the framework. I'm a Rails app, I'm an ASP.NET MVC app. And really you want to think you're an app that deals with these use cases and handles this business logic. And that's what clean architecture is all about. Thank you very much.